Alright, class, let us take a step back and really appreciate how far computing has come, especially when we talk about things like AI. Today, everyone is hyped. AI is taking over. They say machines are getting smart. They can write essays, make art, generate music, even drive cars. There's excitement, but there's also fear. Are we going to lose our jobs? What's going to be left for humans? But let me ask you something. Do you realize there was a time when computers couldn't even understand letters? Not even ABC. They were literally glorified calculators. All they could do was process numbers. But here's the trick. Computers never actually learned what a letter means. They just learned how to map letters to numbers. That mapping is the foundation of everything you type into a computer. So what we did was create a standard, a way to assign numbers to letters, and that's what gave birth to ASCII, the American Standard Code for Information Interchange. And it says basically this number equals this letter. So for example, the number for hello world, capital H, the number is 72. Somebody just decided that the capital H was going to be 72, and then lowercase e, the number is 101, and then for new line, the number is 10. But today we have UTF-8, which on the other hand is a genius format. It stores basic English characters using just 1 byte, just like ASCII, but can expand to 2, 3, or even 4 bytes for other characters. In Python 2, you had to prefix your Unicode strings with a letter U, like U hello, and there were a lot of annoying conversions. But in Python 3, strings just work. Whether it's French, Japanese, or Igbo, it's all Unicode. It's flexible. When you see U hello in Python, that's a byte string dot. It is not automatically readable like a regular string. You have to know what encoding it uses and decode it if you want to manipulate it like text. Efficient and backwards compatible with ASCII. That's why you'll know it's just crossing that bridge between bytes and strings, between what the machine understands and what we as humans want to say. UTF-8 has become the standard for the internet and for data transfer across different systems. You punched in a few digits and boom, math happened. You're usually working with UTF-8 under the hood. Now comes the practical part. When you read data from the internet, it doesn't come in as strings, it comes in as bytes. Python reads that raw data as a sequence of bytes, so you have to decode it into a string using. That was the revolution back then. And guess what? People were scared too. Computers can do math. Oh no, they'll replace accountants, bookkeepers, engineers. Sound familiar? Eventually, something amazing happened. We figured out how to make computers pretend they could understand letters. ASCII basically said, capital H, that's 72, lowercase e, that's 101, new line, that's 10. These numbers, these byte values became the way computers understood the alphabet. So when you typed hello world into a computer, all it actually saw were those numeric codes. Behind the scenes, it's just numbers flying around. Now, in the early days of ASCII, there were only 128 characters. That's enough to cover the English alphabet, mostly uppercase at first, digits, punctuation, and a few control characters like new line. But that was it. No emojis, no Chinese, no Yoruba, no Hindi, not even lowercase letters initially. In fact, when lowercase characters were introduced, programmers were excited. Wow, we can type a now, not just a. In Python, if you want to see the numeric value of a character, you can use the ORD function. Try ORD H and you'll get 72, try ORD E and you'll get 101. This is how Python lets you peek behind the curtain. But of course, the world is much bigger than just 128 characters. As the world became more connected, especially with the rise of the internet, we had a big problem. Computers in Japan couldn't talk to computers in the US because they had different ways of encoding their letters, And that's when Unicode was born. Unicode said, let's just include every character from every language past, present, and future in one unified system. We're talking hundreds of thousands of characters, all given a unique code. But with more characters came more complexity. We needed better ways to store them, and that led to different encodings of Unicode: UTF-8, UTF-16, and UTF-32. Now, here's the kicker. Although UTF-32 can handle all characters because it uses 4 bytes per character, it's very inefficient. So, when you write a Python program and open a text file or connect to a network, and when you're sending data out, maybe you're uploading data, sending a message to an API, or saving to a file you'll need to encode it back to bytes using encode. Here's a simple flow to remember. When receiving data like from a socket, use decode to turn bytes into Unicode strings. When sending data, use encode to turn strings into bytes. This matters especially in Python 3, where all strings are Unicode by default. That's one of the biggest differences from Python 2, but bytes are a different thing. So to wrap this all up, computers didn't always understand letters. ASCII was the first step. Unicode opened the door for the whole world's languages. UTF-8 made it practical and efficient. Python 3 made Unicode the standard. You need to encode and decode when crossing the boundary between your program and the outside world files, network, etc. And now, when you see a Python program using encode or .decode, you won't be confused. So next time someone tells you AI is magic, you lines remember, it all started with numbers pretending to be letters.